And this is not what I'm going to be talking about today, because there are these great tools out there, and it's hopefully not too complicated to get HTTPS set up out of the box. What I'm going to be talking about today is the next step. Because it turns out there are a number of things that you actually have to think about after you get that out-of-the-box HTTPS deployment. It's easy to look at this list and just feel totally depressed. It's easy to think, like, why should I do this? I have no hope of actually getting a solid HTTPS configuration that's going to give my users the privacy and security benefits that they need. That's what we're working on in Chrome. We're working on projects from developer tools, web platform features, reporting mechanisms to help you discover problems that your users are hitting in the wild. All of these projects are designed to make it easy to migrate to HTTPS because we want every site to do that. So this is what I'm going to be talking about today, the projects that we're doing to help you get set up with HTTPS with a solid configuration. And I'm going to divide this into 3 sections. First, I want to talk about that lock icon, the overall indicator of the security status of your page. Because if we want developers to migrate to HTTPS, they have to understand what they're shooting for. And I'm going to tell you about browser tools we're building to help you understand that. Next, I'm going to talk about some web platform features that help you migrate your application in a way that you get the green lock. Because especially for large-scale sites, it's not just a matter of turning on HTTPS. It's very much a matter of migrating your application, and the web platform can help you with that. Finally, I wish I could tell you that the green lock is all you need to think about, but it turns out there are a set of best practices that we recommend you follow even after you get to the green lock. And so I'm going to tell you about some of those and what we're doing to make it easy to roll those out. So let's start here with understanding the lock icon. And first, I want to show you that it's hard to understand because you might think, oh, it's just a lock, it's green or it's red, or it's there or it's not there. But it's actually really complicated, and I get confused about it all the time, and I work on it for my full-time job. So first of all, we have the neutral state. So this is what you see when you visit an insecure HTTP site. It's this kind of neutral page indicator icon, and there's really no indicator of security or lack thereof at all. So right off the bat, I hope this is a little confusing to you, because why is it neutral? Like, there's no security here. Why should this be neutral? It's saying to the user, everything's fine, don't really need to think about it. But in fact, it's not fine. There's no security or privacy whatsoever. So what we're doing, and you may have heard about, is that over the next year or so, we are going to be gradually introducing a negative security indicator for this state, so that when you don't have HTTPS, your site will be marked as kind of a negative state rather than a neutral state, because we want users to expect HTTPS as the norm and see insecure HTTP as an exception. So that's a little bit of a tangent. I'm showing you the neutral state as it is right now. Then there's the green lock state. This is what you're shooting for. This means you have HTTPS set up, everything is good. From Chrome's perspective, we can mark this as a secure connection. All right, then there's this kind of intermediate state. And this is when you have HTTPS, so the page was retrieved over HTTPS, but Chrome noticed some problems with it that is stopping us from marking it as fully secure. And there are a number of conditions that can lead to this state. You might also be used to seeing this as a lock icon with a yellow badge. That was how it was shown until recently, but we recently started marking this as neutral instead of that yellow badge because we thought it was less confusing. So this is this kind of intermediate compromised security state, a number of things that can cause you to fall into this state. And then a similarly confusing one is what we call the red slashy lock icon of doom. And this means that something is really wrong. So in this case, your certificate might be expired, or you might have the wrong certificate, or there might be some really insecure content on the page. There are a large number of things that can cause this to happen. So understandably, when developers see these lock icons, they get confused. They might not know what the lock icon means, and they might not know why that's showing up on their page when they expect to have a nice, shiny green lock. That's why we are introducing a whole new panel in developer tools whose sole purpose is to help developers find and fix problems with their HTTPS configuration, understand what's going wrong, and get to a shiny green lock. So this is on Canary now and on Dev Channel, and I'm going to show you a little sneak peek here. This is what it looks like. You can see it it's its own panel in developer tools. And let me just walk through a few of the things on here. First, we have the overall security status of the page, kind of lining up with the lock icon. In this case, we're looking at a page that's in that kind of intermediate state where the page was loaded over HTTPS, but there are some problems that Chrome noticed that prevent us from marking it as secure. Now, another thing that we're really excited about that we can use the security panel for is helping you keep up to date. Because as much as we wish that HTTPS were something you set up, it was something you set up and then you kind of forget about it and you're good for the rest of time, that's not the reality. You have to keep up to date because there are constantly new crypto systems being broken, new algorithms being standardized, and the security panel is where we're going to help developers keep up to date so that their configuration stays modern. Another thing we see here is information about the security properties of sub-resources. And this is really important because if an HTTPS page loads sub-resources over insecure HTTP, that can compromise the security of the whole site. So we're going to use the security panel to show you information about sub-resources that might have been loaded with different security properties than the main resource of the page load. And you can see there's that link there at the bottom to click into the network panel so that you can see more details with the network panel that you're familiar with. So as I said, this is on Canary now. And also, as I said, its whole job is to help you figure out this landscape and make sense of it. We really hope that you try it. And if you do, feel free to shoot me an email or file a bug if you have any feedback at all, because you're the audience for this feature. So the security panel is what we're doing to help make HTTPS more comprehensible to developers, help them understand what the green lock icon means and how they can get there. But especially for large sites, the security panel is not going to be the whole answer. So imagine that you have a site with hundreds of thousands of pages of content. Many of you probably do. And there may be problems on some of those pages, maybe just a few of them. And it's really hard to track those down when you migrate your whole site to HTTPS. You're not going to open every single page and look at it in the security panel for problems. So I want to tell you about some web platform tools that can help you here. What we hear from developers, especially on large sites, is that a problem called mixed content is one of their main challenges when migrating to HTTPS. Mixed content is this problem I was just talking about, where you have a main page loaded over HTTPS, but you have sub-resources loaded over insecure HTTP, which can affect the security of the whole site. So those insecure sub-resources are called mixed content. What you're seeing here is the Chrome UI when the page is loading, say, an image or other what we call passive content over insecure HTTP. So you can see you're in this intermediate state. You don't get a lock icon. We don't give a lock icon when you have passive mixed content on the page. And we have these strings to help tell the user that there's something wrong. Maybe they shouldn't trust this site fully because there's a problem with its security. So this is what happens for passive mixed content. And you can imagine if you have hundreds of thousands of pages with a bunch of images on them, it can be hard to track down any image that's loaded over insecure HTTP. Here's another type of mixed content, active mixed content. So if your page tries to load a script over insecure HTTP, Chrome and other modern browsers will just block it outright, because it's just too dangerous to run an insecure script on the page. So you'll still get the green lock icon, and you might not even notice that anything is wrong here. But a user might run into some subtle way that your page is broken, and they might click on this shield icon because users are curious and they click on things. And if they click on this shield icon, they'll get an option to load the insecure script. And if they do that, then they're going to end up in the red slashy lock icon of doom. And this is what you don't ever want on your site because it means something is really broken and Chrome can't make any security or privacy claims to the user. This is the case of active mixed content. And again, it can be hard to find this on your site if you have a huge site. So the web platform offers you a way to get notified of mixed content whenever it runs on your site. And this is handy because if your user runs into any of these situations, you want to get notified about it so that you can find it and fix it. The mechanism for this is called content security policy. And content security policy is actually a much more general mechanism, but I'm just going to talk about a few specific uses of it here. So content security policy, it's a header that you send on an HTTP response from the server to the browser. And what the header says is that you want to receive reports whenever content is loaded from not HTTPS. So you can see it has this report only in the header name. That means it's not going to actually affect how the page is loaded or runs in the browser. It's only going to mean that when non-HTTPS content is loaded, you'll receive a report about it. In other words, if a user lands on mixed content on your site, you will find out and you can fix it. I want to give a shout out to this cool service called reporturi.io. And this is a service that can collect and help you analyze your mixed content reports. So you can sign up, and then you get a URL, and you can put that URL in your content security policy header, and then your reports will go to this site, which will help you analyze and collect them. So that you don't have to run your own server infrastructure yourself to handle these reports. OK, cool. So we have a way to find out when a user runs mixed content on our site. There's one step further that you can go. Suppose that you actually don't want any mixed content to ever run on your site. You want it to be blocked entirely. But if that content is loadable over HTTPS, even if the URL itself in your HTML is HTTP, wouldn't it be great if the browser just loaded it over HTTPS and didn't wait for you to go find and fix and update that link to HTTPS yourself? It turns out you can use content security policy for this, too. So in the same way, you can send a header from the server to the browser. And this header says that you want to upgrade insecure requests. So you notice it doesn't say report only anymore, because this is going to actually affect the behavior of the page as the browser loads it. What this is going to cause the browser to do is anytime it sees a sub-resource with an insecure HTTP link, it'll automatically rewrite that to HTTPS. And you can imagine this can be really helpful. So for example, you have a huge site, and you don't want any mixed content to run on your site. But you load a lot of your sub-resources from a CDN, and if you know that CDN supports HTTPS, you can just send this header to make sure that those sub-resources automatically get upgraded to HTTPS, because it can be a massive engineering effort to go actually find and update all your links.